And hello and welcome back. So where we are now, today I'm pretty excited about because I've been thinking about some of the issues that I encountered last week with this project, mainly thinking about kind of how to deal with environments with function calls and things like that. And I think I've come up with more or less the approach that I'm wanting to take, or at least I'll be trying out today. So what I've been or the approach that I've been taking so far is that, when you call a function, it it has its own, say, function environment, and that's fine. But the way I've been working with it, um, function call, so each of those function calls adds its environment to the top of some kind of stack, which in my head was similar to the usual operating system stack you'd have when you're calling functions. But with the way in that variables were being resolved, they were being able to access um, the environment of parent function calls, which didn't make as much sense. And we were getting this kind of logic that I can present here, where so I've this sample code written up from last week where we call x first, and then x defines a variable called a and calls y, and then in y we print a, and the value 3 pops out. Whereas realistically, what I'm wanting to implement here is actually, I'm not sure if what I had before actually conforms to any particular methodology, but what I'm wanting to implement is, I believe, lexical scoping. So, um, so A wouldn't be defined within this scope, and wouldn't be defined in the global scope. Therefore, um, you know, so here's, for example, the program as it is at the moment would output 3, and Z is undefined, as I went through last week, as a result of, for example, the closure and the print down here. Whereas realistically, what I would want is A being resulting in an undefined error when it's called in A, and then if we removed that error, then it would continue on down here to define Z, in which A from this scope gets set to 4, and then printing A would output the 4, and then finally once that function returns, because Z was defined within the scope of X, once we get back to the global scope, Z will be undefined. But we could, if we wanted to keep it defined, we would have to define Z in the outer scope using something like this: Z is equal to null, and we'd have, in this case, this Z would probably override that outer Z. Whether that's the best syntax for that, I'm not quite sure. But the way I'm thinking of resolving this is focusing, I suppose, it's probably just changing terminology really, but focusing on scopes instead of this kind of environment stack. It'll still be a stack of scopes, but the times at which they'll be introduced will be somewhat different. And some subtleties of this approach then as well is, like I mentioned, I believe this is called lexical scoping, what I'll be attempting to develop. So for example, if I do something like a less than 4 in here, b is equal to 2, in the likes of Python is probably function level scoping, so that if you go inside this block, you can reference the variable out here, and then it'll give an error if it didn't go into this block. Whereas in what I'm developing now, because this variable is defined inside the block, regardless of whether it goes inside the block or not, print B will give an error here because this B declaration is only valid inside that inner scope. So it's going to be lexically scoped. So using the scopes or each block is going to introduce its own scope. And so if you define variables, or if you want to access variables outside of that scope, then you need to declare the variables outside of that scope. So hopefully make things a little more explicit. Whether explicitness is something that we necessarily want in kind of a lightweight, say, scripting programming language is something that's up for debate. But I think this is a good compromise between being explicit and being relatively lightweight. So I must just correct the size of my screens here, actually. There we go, and I can shrink that by one more. So where I want to go with that today is to start introducing those scoping rules. And so there'll actually be a good amount to change today. It actually kind of fundamentally changes a number of things. So I've thought of how I want it to work, but not necessarily how I'm going to implement it. Actually, I've just realized. So yeah, I'm just going to try getting stuck in as usual. It'll probably use this, very similar mechanism to the environments that I've been using so far. But yeah, I suppose I'll just get stuck in and see where we go, or how we go, or what have you. So first things first, well, actually, one thing that I need to be aware of as well is that this will introduce a need for this kind of new notation. I suppose I don't need to have the notation available right away, this declaration notation. And yeah, so we can probably do without that for the time being. But yeah, first things first. So will I leave the excuse me. So whether to leave the env type as is and just change the functionality, or actually, because I'm thinking scope might actually be a slightly better name for env, and I'll have to change frame as well. So yeah, I think, and then for this one where it's yeah, so frame will be a singular scope. Oops, I mixed up some types with variable names. So I'll update frame variables to be scope. And then finally I'll update env. Will I update that to be, scope stack or scopes? Maybe ScopeStack would be a little more explicit. But then once I'm referring to so ScopeStack will be the type, but when I'm referring to it as a variable, I'll just call it scopes. Oops. And then env will be changed to scopes. So this shouldn't, in fact, what I'm going to do is I'm going to go back to before I renamed everything, and again, like last week, just going to copy the file while it's in a relatively known good state. So I'll copy val rs and main rs and leave them there like that. So just so that, like, to be honest, I don't think I'll be going back to that version, but it's nice to just keep it back up. So let's see, so scopes. And I think scopes is a slightly more natural name than environment as well, because you don't, I feel like environment is probably more a term from compiler and interpreter design and technology. You don't, like, when you're discussing a programming language itself or going through a programming language tutorial, for example, you probably don't really hear the term environment too much, unless you're referring to environment variables, and perhaps that itself could be a source of confusion. So just for the sake of keeping things maybe a bit more simple, makes sense to, even if we weren't using this approach as such, probably makes more sense to use this terminology. So let's scopes. All right, so so that is compiling at least. Yeah, just double check. Yeah. So so then the next thing is to actually start defining the rules. So luckily, as I think about it, the ScopeStack implementation and how the scope stack is being passed around using, say, parameters and dependency injection and so on, is more or less the way we want it. In fact, the only thing that's going to be different, I believe, is that the times at which we add, I suppose we'd call them scope frames, or the times at which we'd add a new scope to the stack, and the rules for that are now going to change versus the environment, or versus the approach we had before, where before a new environment frame was being pushed on every time there was a function call. And in fact, what I'm going to be doing now, actually, that's still going to be an interesting area. I just realized something about that when we're doing a function call. Oh, I had considered that before, actually, during the week. So when we're doing a function call, we'll clear the stack more or less. So we'll remove most of the scope stack when we're calling a new function, and the new function will only have access to the global scope. However, if it has if that function that's being called, it could have a closure, in which case it will have its own, I suppose it'll have its own stack associated with it, but not from the call point. It'll have a stack associated with it from the point at which it was defined. So so in that regard, we'll be at the mechanisms for maintaining the scopes will be, I think, fairly straightforward for most other points. So when you go into an if block or just a regular new block, in general, it'll introduce a new scope, and when you exit the block, it'll pop off that scope. But then in the case of function calls, it'll still be a little interesting, but it'll be a different mechanism to what was there before. So to start off with, I'm going to look for the call evaluation. So when we do a call, we evaluate the parameters. This gets the function, the definition of the function. So that's the function name. It grabs that from the current scope or the current scope stack. And then if it's a built-in function, it'll call it directly. But if it's a function that we've defined previously, or if it's a non-built-in function, then we have special semantics for it. We'll probably abstract over the two different types, so abstract over built-in functions versus regular functions later on. But for the moment, this approach is fine. So now what we're going to do, so we create this new scope, which is good. So we have a new scope based on the parameters being passed to the function, and that gets turned into a new scope pushed on the oh, there are a few variables like that, so that's scopes prime. Was there something like that in main? No. So here we're going to have scopes like that, but what we're probably going to introduce as well is there's the function value itself. From the time it gets defined is going to have its own closure, which is going to be a scope stack from the point at from the definition site. So if we go to at the moment, yeah, functions are being defined as statements. So what we can do here, yeah, that could be fairly straightforward actually. So it should just be a matter of cloning the current environment at the point at which the function gets defined. So if we go closure, and that would be scopes clone, and this should be fine because this is just a if I go to definition of ScopeStack, that's a vector of atomic reference counted variables, and so I can clone a vector very easily, and that can then clone all those references. So then we have a closure variable in here, so I'll just need to add that to the definition of a function. ScopeStack. And then in here, when the closure is being used, so instead of using the current scopes, it'll actually use the closure. Now we don't want to destroy the original closure, because if we call this more than once, we want it to be all right. So we'll probably have to clone that there. And so that should be about what we want. Now, I had wanted to actually do up some code to almost do a bit of TDD here, where I define how it should look at work before I actually used it. I'll do that now. The code isn't compiling anyway, so that's probably a good opportunity to define the semantics here. So if I do something similar to what I had before, so we have a is equal to 3, define function z here, a is equal to 4. Now this, yeah, so this will be tricky because I still don't have that what's it called? I still don't have the declaration syntax yet. So what I can probably do in the meantime is, I won't be able to test whether I can assign to outer variables, but at least I can find out whether I can access outer variables. And I'll define something in the global context here as well. So the result of calling x should be, let's see, I'll call y here and I'll call z here. So it should output 3, which is the value of a first, and then it should output the value of b, which is 1, defined in the global context. So yeah, so let's try and get this thing running. So 4 errors, 404 stack, ScopeStack doesn't implement debug. Interesting. So let's just add that on. And it's clonable anyway. But we probably need to, in fact, do I need to derive that? Yeah, I need to derive clone as well. Interesting. Yeah, because it's its own type. It's a new type, so it doesn't inherit anything. And actually, that worked pretty smoothly. So these are accessing the outer scopes as expected. Now, I just want to make sure that the mechanics around the global variable are correct. So when a function gets called, in fact, yeah, how is that working? So what could be happening is function x, at the point function x gets defined, it's not that these are accessing a global. So I didn't add in any explicit handling for the what we could call the global environment. What is more likely to actually be happening in this case is at the point x is defined, it is itself creating a closure over what we would consider the global environment. So there's no actual explicit handling, because what I was thinking is that no matter what function that gets called, we'll have to even if it has its own closure, we have to clear all the other scopes out of it and just leave the global scope. But because each function is at the very least going to be defined within the global environment, then all functions are by nature, I believe, going to have a closure over the global environment and so are going to be able to access that. So that's actually a really interesting thing and a really neat thing to just kind of get for free to a certain extent. So so nice. So that's the function scope parts working. And now, yeah, like the next thing to consider is, yeah, whether whether I do want to just keep function scopes, or if I want to be a little more strict with with the developers in this language. So what that would mean is if I had, for example, so if a is less than 4, so this is always going to evaluate to true, and we're going to have C in here, and C is 5, and I go print C, then currently this should be fine, because even though this is being defined and you initialized within an inner scope, scopes are only being defined at the function level. So this is actually going to be defined within the function scope, and so when we reach here, it's actually going to be fine. So it'll be 531, I believe. Yeah. Now, it might just be me, but I do find this somewhat, I suppose, confusing to a certain extent, because coming from a lot of other languages, especially statically compiled languages or statically typed languages, that's not allowed, so that wouldn't be available. So it in that sense, it kind of is somewhat unexpected as well, and I feel like it's somewhat dangerous. Not too dangerous either, but it is dangerous from the point of view of it, to me, encourages a sort of a bad habit of not having kind of exhaustive coverage of potentially creating this code that glosses over edge cases, which often then can come back to burn you. So the way to work around this, or to force the developer to be more explicit, is that in each scope, or each new block, that introduces a new scope. So eval statements actually could, so this new scope could be introduced here, because eval statements could be almost renamed to eval block, and that could actually make some more sense in general. It does cause a bit of redundancy with eval prog here, because there'll be another scope, like it'll create basically an empty scope on top of the global scope. That's kind of interesting. And sorry, this is an interesting thing, because what that means is, technically, if we have this kind of extra invisible scope that's always added over, say, so we have this scope being defined in main, when you could consider it a prelude, where it's always defined, it's just got all the built-ins. For example, at the moment it just defines print. By creating this veneer over that scope, it does mean that you can't necessarily delete, well, you can override variables from the very top level scope, and you can shadow them, but you can't really delete them as such. Although no, you can really. Yeah, because if there isn't anything in your local scope, then you'll be accessing the outer one. I won't get too bogged down on it. It's an interesting thought. I'm not sure whether it's for better or worse at the moment, but what I'll probably do as just somewhat of a hack really is I'll update scopes so that it clones the outer scope. And I'm pushing an empty scope here. I'm passing it down there. And if I, oops, let's see where the call is again. Oops, there we go. And what's being done here? It just pushes, and so in this case it'll be an empty scope. Yeah, so it'll just be an empty hash map. What's the best way to create an empty hash map in this case? Just do new, is it? So this function takes one argument, but two are supplied. Does hash map new return two values? Associated function defined here, 420. Okay, I'll have to debug that some more. Let's scope equal this, and oh, I have to do it like that to interesting. Not the most obvious syntax, I feel, but that's just me. Line 24 then. Expected a mutable scope. So I'll have to borrow it explicitly. And I'm going to open a window here because it's, anyway, this should error. Oh no, it didn't. Why is that? Is there a valid C in that scope? So yeah, I'm just going to open a window, but I'll be back soon to debug that. Okay, so let's see. So it still prints 5. And in fact, just to double check, what happens if we send that down to 2? So in this case, we get the expected C isn't defined, but I'm expecting that here as well. So let's see what's happening here. So if I scooch that window over a little, and let's see. So I'm looking for definition of if, and it should go into eval statements and scopes, and then scopes should have in fact, this could be cool, is to just print the value of scopes at the exit point of each block. So in this case, it would output the value of the scope just here, I think, and it'll also do it at the end of X. So let's try that. Ooh, what's going on? So there's a lot defined in here. Oh, can I pretty print the debug output? Rust pretty print debug. So is that a pound symbol? So if I do that, yeah, so that's a lot of information, but it's probably a bit easier to read. So how many things are being, okay, I'm getting a little lost here. So I'll go to the bottom again. So this is, okay, maybe I'll scroll up until I see that compile symbol. Okay, yeah. So the first ScopeStack gets output before 5 gets output. And in fact, I'll scooch this back over again so that's a bit bigger. And close that and that and that. So first is being output before 5. So that's presumably the end of this if statement. So at the end of the if statement, what is the ScopeStack looking at like? So first of all, so at the top of the stack, A and C are defined. That's interesting. I would have thought C would be defined within the inner stack and then be popped off, but let's take a look at what's defined outside it. So the top of the stack contains, and that's nice actually, it's accessing the data inside the mutex. I hadn't considered that it could have just given us a reference and been not very helpful. So X is defined in the outer scope. That makes total sense, and it's got those statements. So X is being defined in the global scope is print. Interesting. Why aren't those being defined? That's interesting. So I would have expected print to be in its own scope, and then X and what else? Oh, B is being defined in this layer as well. So I would have expected B and X to be defined in their own layer, but print to be defined in a different one. So I could have things a bit backwards. So what's happening here? So eval prog, so starts off with the scope stack being having one element, I presume. Might be no harm to output the scope before evaluating the statements as well. And maybe I'll call this inner scopes. You know, have slightly better names. So what I would expect is for this to be on its own line, or in its own scope, B and X to be in their own scope, A to be in its own scope, and then C be gone. Maybe I'm not using eval statements for all of these. I might be using some kind of shortcut for functions. So let's look at all the things that should have blocks. So an if statement should have blocks, and those should use eval statements. Yeah, a while loop should have a block which is eval statements. For loop uses eval statements, and a function, that's a function statement. Then what else do we have? That's an assignment, assign a list, evaluate an expression, and then what kind of expressions do we have? We have a list that we won't really have statements within a list, so that's all right. An operation, a variable, and then the function call. A function call evaluates it within a new scope as well. Yeah, am I better off, instead of kind of hacking it into the eval statements function, actually passing it in directly, because that's what yeah, that should probably be passed in as a parameter, but that still doesn't explain why that's just kind of sloppy code rather than something that should cause what we're seeing here. What does inner scopes look like at the end here? It's going to give a lot of data now. I'm not sure if I'm going to be able to reach that that green compilation symbol at the top. Oh, there we go. So in this case, we have bx and print. Oh, it's mad. I should be getting 2 scope stacks before 5 is printed out. I mean, they're printed at the same time. Outer scopes. We'll do them in the same println, so then it can't. Oh, I should probably use a different okay. So all the ways up to the green part again. Did I miss it? Probably. Okay, yeah, so I'm running out of stuff. So when does X get printed? Or, oh wait, I forgot that yeah, it would happen with y and z as well. So when we exit y and z, we'd get a load of output too. So to simplify things, let's just remove everything but x. Oh, and I forgot, because the last time it probably didn't even compile it. It probably just ran the program. Okay, so what's the scope looking like? Oops. What's the scope looking like for the inner scope? It looks like it looks the same as the outer scope. So we've got the mutex there. I just realized that I didn't do an arc mutex blah-de blah for this push either. What's even going on here? So I cloned outer scopes. Well, I have a thing on ScopeStack though, don't I? So when I do a push, it that's on me. That's totally on me. So I changed. So I mixed up accessing the vector directly. So this is a non-destructive push. So maybe I should rename it so that and this is especially because this one is a destructive insert then as well. Push on new, maybe. Is there a naming convention for this in destructive update names, maybe? Like the way is it scheme or common lisp have the bang character or the exclamation mark? Non-lexical, non-lexical lifetimes. No, I'm not going to spend too much time on that. Maybe push. Push new, push on new. New and push. New from push, maybe. Yeah. That was, yeah, very silly. Very silly of me. So I have no one to blame but myself. But I'm glad that the kind of that the reason made sense and was grounded in reality. So line 21, inner scopes is made from the outer scopes. And in fact, if I remove print line now, new from push method not found. So I didn't actually rename the, yeah. and C isn't defined. Brilliant. That's just what I wanted. So I can remove that stuff. And when I do the same here, should get the same result. So that gets popped off. So I would have to initialize it to have a default value first. Unrecognized token, yeah. And yeah. And that's not working because I don't have declaration syntax yet. So it's actually defining it within that scope. Like so because at the moment it's a declaration and assignment syntax rather than splitting up the two. It means that this is being declared within this new scope, and so shadowing the outer variable, meaning that once we get to the print statement, it's printing the original C. But that's something to resolve next. So next thing to do is, yeah, I should probably especially because in the case of this, it pushes the new scope. Maybe I'll have eval statements with new scope. Just as a shortcut. Oops, where's my cursor gone? And I can get rid of that. And then the rest of the eval statements. Be nice to have some type level way to make sure that I'm calling these at the right time. Maybe if I actually took the, yeah, so I can enforce this. By taking the inner scope as a parameter. Yeah, that makes sense, I think, to me anyway. So inner scopes mutable, and then what do we have here? That's kind of nice. And then, so all the ones that need to give a new environment, or so all the eval statements need to give a new scope. But they can use this kind of optimized, or not necessarily optimized, but this kind of shortcut function if they're just going to be using a blank scope. And this eval statement, unless eval prog, yeah, I'll just do that again. Hello, Highsam Dragon. Thanks for joining in. So so this will be evaluated in the new scope then. This it would probably make more sense to collapse the scopes here and not necessarily add a new one in this scenario, but I'm not going to worry about it unduly. What I'll just do is add it to do statement for. Yeah, thanks for the question. So this particular programming language is called Norpl. So standing for not a real programming language. It's more or less a skeleton basis for my oh yeah. So the name for it is, and again, I really have to upload this to GitHub at some point once I tidy it up a bit. But it's called Norpl, and it's going to be kind of a skeleton language, which is a stripped down C-like language, which I'll be using as a almost like a research tool to define another programming language. So my ultimate goal with this project and the project that comes after it is to essentially, it's been tried a number of times before, but I want to take a stab at it, which is defining a replacement for bash and bash scripting essentially. The idea being that bash does, a lot of things, it's functional, but I suppose there are a number of things about it, such as the slightly unusual syntax, the use search for a right syntax for a programming language. Exactly. So the idea is to play around with different alternatives from a kind of a solid basis. So I have a number of features, for example, that I just kind of am fairly certain about. So things like, there have been kind of a lot of modern, say, developments in languages and a lot of, say, new ergonomic features. For example, Rust can have quite lightweight, Rust and Go and similar things can have quite lightweight kind of, say, for loop iterators. Things like JavaScript and Rust and other languages have very nice pattern matching and object destructuring and restructuring and spreading and unspreading of arrays, which are kind of very nice lightweight tools that I feel can really help overcome some of the, say, trickinesses around that Bash has. So, one example of a neat thing that I'm hoping to do in this new language, for example, is, so if I full screen this, so for example, I'm not even, Bash has these interfield separators, IFS, I think, and it defines how you're going to split a string based on certain characters, and to be honest, I don't even know the syntax. I find it quite unwieldy, but the idea is to replace that with just kind of more general split syntax or split functions. So for example, if if I had to loop over some stuff that got returned from a git call, so your typical, git call would be git, I don't know, log with some filters. Again, I'm not even sure the syntax here. I'd be looking it up at the time, but and then you'd have this kind of a notation to grab it all. You'd grab the output. You'd probably set your IFS to whatever, and extract field, loop through the fields of it, like this. Whereas the idea of this language is to still try and get the ergonomics of Bash, because the fact is, while Bash can be quite clunky in a number of areas, in my opinion, such as with if statements and things like that, like just, when I was learning it first, I had to look up the syntax so often that I'd get a kind of more regular C style syntax for all of this, but get all the niceties of more modern programming languages, while still keeping some of the ergonomics of Bash, which are, for example, if you try to do something similar, like I was thinking, you can still write, or you can still script pipes and command, program calls and things like that in the likes of Python with popen. You have exec in Go and things like that. But it ends up looking a bit like, you have something like popen and you've a bracket and you say git log and so on, and then you set up your pipes and you say standard out is equal to that, is equal to popen probably pipe, and then down here you have this, or you have your process here, and you have popen. You say where all these different pipes are going, and it's almost like a layer on top of that, whereas Bash is just kind of, and Shell in general is a lot more succinct for those kind of things. So the idea is to keep the succinct nature of Bash, but with perhaps a more lightweight, uniform syntax, and also, more in term, I suppose, more of a natural programming language feel, in my opinion, anyway. Well, I'm only a beginner. I lost track of what I said. TLDR, want to make a programming language that'll replace Bash. Essentially, yeah, that's kind of the goal. It certainly won't be a general programming language. So one of the major areas where I'm not going to focus attention on, even though it's something that means a lot to me, is, for example, error handling. So the utility of this will be, it'll be a scripting language. So it's not going to have things like comprehensive error handling. It's not going to have, it's not going to be set up for great networking. Not necessarily for stream processing either. It's going to have, say, just kind of very lightweight primitives to allow you to ideally write scripts that feel like Bash in a lot of ways, but just with much more kind of a regular feel and logic and consistency, at least based on what I think a lot of people are more used to in terms of programming, which a lot of the time, C style programming languages like Java, JavaScript, C itself, C Sharp, Go, Rust, all of these kind of things have this kind of similar feel. And it's, that's one of the things for this as well. But there are going to be compromises, and this language is to decide what are the compromises that make the most sense. So this will be the basis for that language. Well, it wouldn't be Python syntax as such. It would be more like C style syntax. So it wouldn't be indentation. It would be using braces and blocks. But there will be elements of it inspired by Python syntax. Definitely, to be honest, it'll be taking inspiration from a number of I suppose the most mainstream programming languages. Cool. Thanks very much for the questions. So So yeah, let's see. So I'll just close this this bit down. So yeah, where was I? So adding a to do in here, eval statement. So this introduces a new redundant scope. Be considered to bundle this or to squash this new scope into the global scope. So I'm not going to worry about that for now. So where are we at the moment? So just a few errors to resolve at the minute. So line 31, a local variable with a similar name exists. So this is just going to be scopes. And it defines the inner scope. And then line 364, what's happening here? Evaluate statements, and this one is going to use the new inner scopes. Or no, I don't actually have to I don't have to, because I can pass the outer scopes and I can create the new inner scope, or I can pass the new inner scope directly. Inner scope, and that should fit on that line. Yes, just about. So I'm not breaking my 79 character limit. So 363, although this doesn't matter too much on this branch because it's more work in progress. But so let's see, line 6.3, can't borrow as mutable, try removing the mute. So where is scopes here? Can't borrow as mutable, no? Whoops. Now, why is that? As it's not declared as mutable. That smells fishy. I feel like it's declared as mutable. So why did you choose Rust itself? Yeah, good question. For this, the implementation of this language, the the target language, so the language that I'm implementing, is intended to be lightweight, but the source language, or the language that I'm implementing it in, doesn't really matter too much what properties it has to a certain extent. I just like Rust. Part of the reason is I was just looking for not looking for a project to implement in Rust, but for this project, I was happy to use Rust for it. And plus, I do like the safety and mechanics of Rust. I think, because this is just a kind of a hobby project, I'm happy to use Rust for it. Rust isn't probably a language I'd necessarily use in a, say, a business setting, if I had to get a product to market, unless it was, say, a mission critical application that, people were, potentially lives or things like that were depending on it. I would definitely use Rust in that kind of a situation, I think. But for this kind of a hobby project, just wanted to basically, it has introduced some challenges, as may be seen in some of the previous streams, which I'll be putting up on YouTube as well. But yeah, it's I suppose to simplify it, just wanted to write something in Rust basically, and this I think this project kind of lent itself to that. well enough. So, yeah, thanks for the question. So let's try just removing that there and see what. So that actually, that's all right. And so then line 359, what's the issue here? The closure isn't being, I should be passing closure here as well. And I should mutably borrow that. Is that possible though? What was I doing before actually? So I had, oh, I was closing, or I was cloning the closure. And I still need to make it mutable. Cool. And how do I fit this on one line? Results. Left closure. No, have to do that. And that's breaking my line limit. Ooh. Yeah, it doesn't matter too much here, I suppose. Yeah, let's just go with a bad variable name instead. Okay, so so that's that done. Cleaned up a little bit of the scoping rules. So that means that every time we're going to evaluate a block, it forces us to provide a new scope for that block. And we have this kind of helper function as well, that if we know that the new scope is going to be empty, i.e., unless it's a function, it's going to be empty. So this allows us to just introduce that in a lightweight way. All right, so so the next thing to do then is, let's see here. So there is this issue of, for example, if I have, in fact, I'll bring it to the top level. And so here we have an expression. So we define C, or so A is equal to 3, C is equal to 0. A is, or 3 is less than 4, so we should go into this block. C will be evaluated to 5, and then we print C. And even though we'd probably expect that to be, we'd probably expect C to be 5 at this point, because this is in an inner scope and isn't assigning to the outer variable. Because we don't have variable declarations, this is going to output 0 for the outer C. So what we need to do in this case is introduce a notion of variable declaration. We could work around it in other ways. Again, like I mentioned, Python and PHP do things like having a global keyword to, you don't declare where something is, but you can say that you want to access a global variable. I feel like this makes a little more sense to me. And again, I prefer things to be a little more explicit, so we'll go with this approach. So we're going to have a new, so we have assignment, and so we're going to have a new declaration assignment. So we're not going to have a standalone declaration syntax. So At least I don't think so. So that means you're always going to have to, assign a default value, and in general, that you can just assign that to be null if you don't have anything better to put in it. But the idea is that instead of having, for example, 0 values or uninitialized data or uninitialized variables and things like that, we're just going to do away with those by saying you have to assign your variables when they're declared. So there's going to be declare, and that's going to have the same stuff as an assignment. So it's going to have a left-hand side and a right-hand side. And so that's what it's going to look like. Then we're going to define how it's going to be stored in our AST. So again, it's almost identical to an assignment. So we can just use the same setup there. And then the last thing we need to do is actually eval or add evaluation rules for this. Not sure if the sound from the ice cream truck is coming in through my headphones, but it's very loud from where I'm sitting. So again, declare it in the same area, or use the same rules as an assignment, more or less. But the difference here will be, in fact, we're going to use what used to be the assignment logic. That's actually now only going to be the declaration logic, and assignment instead is no longer going to create a new variable. So before, let's see where the assign function is defined. So we have assign var, and assign list. So eventually everything, I believe, resolves to an assign var. And now, at the moment, what it does is assign var takes the basically, just inserts a new variable into the narrowest scope. So it'll shadow anything on the outside. Whereas what we want is for an assignment. So in fact, what I'll probably do here as well is split this into declare and assign. So insert is just which is what we had before, is just going to be declare, which is just going to take the innermost block and assign basically, just insert that name with that value into the narrowest scope. However, for assignment, what we're going to do is we're going to look back through the different scopes, and only once we've found the variable do we actually assign a new value to it in that scope. So what we're going to need to do as well is have a boolean here to indicate if we didn't actually find it. So for scope, we unlock it, then we try to get that variable, and if in fact we don't need to actually get the variable at all because we'll be assigning it. I wonder if Rust itself just has something for that. So that was a hash map. And let's see. Again, I'm going to be this time in contrast to previous weeks, I'm actually going to be looking at the methods in this section below. Oh, there are no extra methods. Interesting, because there was a bunch of methods down here in vec last time I checked, because I hadn't seen them originally, and it confused me. But HashMap seems to basically just have everything up here, so that kind of simplifies things a bit. So what I'm looking for here is where we unlocked frame. So maybe replace, something like replace or insert if present, or just to see if there's kind of a slightly optimized version. Contains key is what we're looking for here, and it returns true. So yeah, in fact, we probably want to do this atomically as well for kind of safety purposes. Try insert, that sounds, oh, nightly only though. Tries to insert a key value pair and returns a mutable reference if it works. Oh, that's only if the key wasn't there. What I'm wanting to do is only update the key if it is there, which probably is slightly unusual, but maybe remove entry would work for this. I'd still be splitting up the operation into a removal and an insertion, but at least in this case, it would remove the tau problem where you check whether some condition is true, and then you operate based on that condition. Whereas this would actually just perform the operation and fail if the condition is false. So that could be an option. So there's remove and remove entry. So remove entry gives you the key and value that was there. I don't actually need the value. Just need to know. Just need to replace the key. Or in fact, no, that doesn't even matter. So I don't have to worry about tau because I have a lock on the frame, so I'm the only one able to access that. In fact, that shouldn't even be called frame anymore. Those should all be called scopes. Nice. And so I don't actually have to worry about, I'm just so used to kind of thinking in terms of atomicity and not dealing with locks that I don't even think about that, or I forget that if I have a lock on it, I can just access it however I want. So what I'll do is contains key, and if it does contain the key, then I will insert into that frame, or into that unlocked scope. Insert, and let's see, what do I want to insert? The new name, or same name, with this value, and then I'll return true to indicate that the operation, that the assignment was successful, and false then otherwise, and false will eventually be will snowball into an actual error then. So let's see, assign returns true if, assign replaces name in the topmost scope of this scope stack and returns true, or else it returns false if name wasn't found in this scope stack. All right, and then so what that means is, so we will have to update assignment because it'll be handling both assignment and declaration. So first of all, so this will be different based on whether it's a declaration or an assignment. So so it's going to, this is going to be using more or less the same logic for both declarations and assignments. I don't necessarily want to use a boolean flag to swap between the logic. What's my best way of implementing this? So there's declare and there's assign. Okay, I suppose I'll start with a boolean flag. So I'll start with a boolean flag and then refactor later if needs be. So this will return boolean yeah, there's lots of assignment functions and 99% of them are going to be the same for both cases, for declarations and assignments, I think. That's an interesting thought, actually, is there going to be slightly different logic for destructuring if I have different syntaxes for declarations and for assignment. So if I have x or a b and that's equal to 1, 2, actually that would be kind of interesting. So if I have A and B there, so if I have A is equal to 0, one will overwrite A and B will, or sorry, so these will be declared in this inner scope and be popped off at the end of if, so print B will fail. If I do this, then A will overwrite, or one will overwrite the outer A, but B will fail because it's not defined. I think that's actually what I want. Yeah, I think so. So, and I just need to make sure that the results get propagated correctly. Yeah, I'll have to update all of these to return a bool, even though it's only, yeah. So assigning. Declare. I'll just do it like this for now. I'm going to ignore my, in fact, I've been breaking my character limit here anyway, so it doesn't really matter too much. Yeah, we'll just do it like this for now. I'm not going to worry too much about boolean flags and that kind of stuff. We'll clean it up after. So if declaration, then we'll do that. Otherwise, we'll do an assignment. So if name is equal to that, then we'll return true actually. So we'll do it like this. If it's a declaration as well, then we'll return okay, true. Otherwise, oh, in fact, oh no, I can simplify that a good bit actually. So what I'll say is I'll turn it into an error right away. So I won't worry about returning bools and so on. Yeah, that makes a lot more sense. If I wasn't able to do the assignment, then I'm going to return an error. And what's the error I'll return? Something about it being undefined. That isn't defined. Right. All right. So so that's the error, and so that's if it's a declaration, yeah. And in fact, now that the error handling is uniform and I don't have to actually return a boolean throughout, I can actually take the assignment function as a variable potentially. So what I could do here is, let's see, so first I'll open this. Oh, there are a lot of errors. So assign. And for loop is naturally a declaration. So I don't actually need to pass scopes anymore as such. I could actually pass the scopes function. No, I'd have to close around it because assign does additional processing. So so I'll do is assign This is tricky, all right. Well, not tricky, but it's just figuring out the best way to pass this without making a big old mess of things. But I don't know what to say. That's no problem. No, sorry. I get very in my head sometimes. So what I'm thinking is here that we have some kind of leaf operations. So kind of some functionality deep in the call stack that I want to abstract. And what I'm thinking is really I want to pass in a function that will do this stuff for me. I'm just thinking about the best way of doing that. So so to start off with, so I'll just call this assign prime for the moment. And so if I did an assignment, I could, and again, I forget how to do Rust function closures. And the reason that I want to do a closure as opposed to just passing the function itself is because I need to operate on the result. So it'll take the name and the right hand side. Yeah, it'll need to take the name and the right, the left hand side and the right hand side, or the name and the right hand side, and it'll do scopes. In the case of assignment, it'll do scopes assign name right hand side. But if there's an issue, so I'm going to put this functionality in to there. And so declaration prime, and again, this is more just playing around with ideas rather than what is necessarily going to be the final logic at the moment. But oh yeah, and this is going to also take LHS, RHS, and declaration won't be needed anymore. That's for the better. And in fact, I can call this, probably don't have a good name for it actually, but I really want to take it out of that parameter list. Oops. Whoops. And just call it F for the time being. And then declare prime will be basically the same. But instead of assign, it'll be declare, whoops, not declare, and it'll just return okay, empty, or unit. And same for that. So that makes sense to me anyway. The next thing to do is to just pass that function closure throughout, and say, and then in here it'll be actually used. So let's see, what's the notation? Closure annotated, yeah, so it has types. FN once, I think is what I want to use. If only just because I know that I only want the function to be called once. In fact, assign var. In fact, maybe I'll call, so these are all called assign at the moment, but maybe I'll rename those to bind to distinguish between assigning, declaring, and the actual binding that's happening. So we've got bind, and if that'll be an error, again, that's something I need to handle in a minute. So yeah, at the moment, what I'm doing is, yeah, basically, it's kind of a mix of implementation and refactoring. So it's kind of tricky to actually, excuse me, it's kind of difficult to narrate exactly what I'm doing because I'm somewhat making it up as I go along as well. That should be bind, not bond. And let's see. In fact, like, I don't really need bind var if I'll call that bind name, even though it's kind of the same thing. Anyway, bind name is fn once, and again, what's the syntax for this? Oh, it has to be a type parameter of function. Fn once. Oh, so it's a where thing. Oops. Oops, where. So where goes second, and f is fn once, bind name is an F, and then you take the parameters like that. So it's that result string. Okay, and function once takes a name, a string, and an RHS, a right hand side which is a value, and that is about it for that. And then I do the same throughout. I'll probably put the scope and binding functionality into its own little file eventually as well. I think that would make sense. Makes sense to me at least, because it's, you know, it's all fairly cohesive. Anyway, enough rambling, more coding. So let's see, assign list, same thing, bind var, whoops. No, bind name is F. And now I can, whoops, can rename assign to assign. And that will be changed to bind. And let's see what next. So I'll have to update references to stack throughout as well, or scopes, I mean. I am somewhat scared of the errors that I'm going to be getting, but I'm fairly comfortable with the approach that's being taken. I think it will be a reasonable and valid approach, and shouldn't require too much fixing. And let's see, scopes will have to be, whoops, renamed to bind name, bind name, and then, yeah, I'll need to update okay, we'll try that. And then for the error messages, assign okay. That was a big load of implementation without too much actual running of the code, so kind of nervous to see what the compiler is going to come up with, but we'll see. So line, so those are all in main. What's happening in main? I feel like I haven't touched that in a while. So what's the issue here? 36. Evaluate program wasn't found in eval. Oh, because eval wouldn't compile. So or like there's actual syntax errors in it. So let's see. So you can't actually put names in those function types. which makes sense. I think that's fair. Yeah, so let's try that out. And yeah, we've a lot more errors now that eval is compiling. So let's see, line 50 or line 500. No method name contains keys on mutex. Contains key. Okay. Phew. That was simpler than expected. So 500 expected a reference, found a string. Try borrowing it. Okay, that's one error down. Let's see. Consider removing the semicolon. Line 211. Oh yeah. And same for up there, I would assume. So line 97. Yeah. So let's see. There's scopes insert. So now instead of assigning to scopes directly, we'll be using the helper methods. So an operational assign, that would have to be an assignment because it has to retrieve the object out of the scope anyway. Let's try that. That seemed to not do it. Mismatched types. So assign scopes left hand side, right hand side. So line 97 again. Expected an expression but found a string. Oh, because I need to do. So I'm calling some of these directly. So I need helper functions for more than one of them. That makes things somewhat trickier. Maybe maybe I could do it like and return a yeah. I think narration is going to go somewhat out the window for the moment while I kind of figure out my own thoughts about what I'm doing here. But basically doing a mix of using first class functions and other kind of silliness to get the declarations and assignments just working the way I want them. For the most part, I think the logic itself is fine, more or less, but yeah, this is basically just tidying up the code at this point. So this is going to return an F. Where F is an FN once. That takes a string and a value. And I'll do the same for assign. Now I'm not sure if this is necessary. Again, I'm getting into the part where it's more art than science. But I think what I'm doing makes sense. Can't find F in the scope. Bind exact list 316. Put it in the where now. Oh, do I have to use type parameters for those? Okay, I see. In that case, I have to update all of these. And 201. I have to do the same, and this will be assign. Not loving the indirection here, though, is the only thing. Like, it potentially would be simpler to like the indirection with the closures and things, it potentially would be simpler to just pass a boolean flag to say whether it's a declaration or an assignment, but yeah, I suppose I'll worry about that later. Expected F because of return type of this parameter, but found a closure. Oh, okay, so I can't return a closure here. Can I do them as output parameters? No. Rust out. Return closure. Is that even possible? An infiltrate. Like this again, a little complicated. Yeah, it really is getting to the point where, like, I know Boolean Boolean flags. Was that as far back as it'll go? Oof. Maybe I'll just redo all the changes and update manually. Yeah, it gets to the point where, you know, just because something's a best practice doesn't mean it's infallible. And in this case, I think it just makes more sense to have a Boolean flag to say, okay, this is an assignment, you know, call this function if it's true, otherwise call that function. Declaration. Or And again, we can make this a little bit smarter by doing something like, or not smarter, but just clearer, hopefully, by saying enum bind type, and this can either be an assignment or declaration. Can't remember how enums look, but I think that's right. And yeah, we'll just do it like that. Again, not necessarily ideal, but I do think the overhead of messing around with kind of anonymous functions and closures and things like that in Rust is actually going to make things more complicated to type out and use, or type out and read. So at that, it gets to a point where it's just not worth it. And maybe, maybe there are ways of doing it in a more lightweight way, but I certainly don't know what that is. So I mean, this project is partly to help me learn Rust a bit better anyway. So I'm certainly not at the stage where I can try out all those fancy things just yet. Oh, there's a bit of stuff needs doing here, alright. In fact, I'll get these back, copy those, redo all my changes, and then up here, I'll say match bind type. And bind type is either assign, in which case I do one thing, otherwise it's a declaration. I didn't say it, I declared it. And let's and get rid of those again. Don't need them anymore. So it's just gone 5 o'clock. I'll probably keep going for a little bit longer, but I will need to take a break at some point soon. Definitely grab a glass of water. Okay, let's see binding. To yank word. Yep. DT prime. Ooh, didn't copy that correctly. ScopeStack. BT bind type. And there we go. And 11 errors now, so 226. Yeah, so I'll have to update a bunch of function calls as well to use the new parameter layout. That should be all right though. And let's see, line 241. Expected. Oh yeah. Uh, 305. What's going on here? LHS can't be found. Not quite sure what's. Oh, I've been silly with my commas. Is that the only occurrence of that? 179. Okay, assign var. And there's going to be assign type. Let's see. So this is going to be a function. It's a function declaration, and so it's going to be assign type declaration 179. It's kind of interesting to make it this explicit. Assign var isn't found in scope no, because it's now called bind var. 162. Again, bind isn't found here. And this is going to be, what's this, a for loop, so that's going to be a declaration as well. Um, 97, bind that, that's an operation assignment, so that's going to need to, that's the one from before where it's going to need to be an assignment. And again, so I've been using assigned type, so it needs to be bind type. 97, that's the line on. Line I'm on now. 97. Expected. Oh, what was this function called? So that was assign. But it was on scopes, so it'd be bind name perhaps. Or bind var. Maybe bind name would be a better. Yeah, I'm going to call that bind name. 73. Whoops, not 873. Not found in scope. Bind type assign. assign doesn't quite match with declaration. It'd be assignment, wouldn't it? Or I could rename declaration to declare. Probably makes more sense to call it assignment. And then line 60. Not found in that scope again, so that will be bind, and that's declare bind type declaration. And that's the new one. And here come the borrow errors. So 480. A move occurred with BT. In an iteration. Will I implement copy for that? I feel like that would be the simplest approach. How do I do? Yeah, it's oops, drive. And I want to copy from that. Trying to clone is not implemented. And 228. Move occurs because of that. Value moved in the assignment. Can I just do that? 484. Maybe I could do a clone. Okay, so it's compiling now. So let's see. Yeah, compiler error. So let's see if that'll just even work as is. Panicked. So is that a token error? Unrecognized token opening bracket? Yeah, because I don't have any. In fact, what I'll do, no, I won't do it for now. If a is less than 1, then we'll go into that. And so we should get a b isn't defined error. That's very cool. So, so if we go a and b, and we declare both of those at the same time, then a and b should be equal to 1 and 2. That's very nice. I like that. I'm very happy with that. I think that's a nice approach to me. And it deals with shadowing and referencing variables. It allows us to kind of define variables in different scopes and reference those different scopes, and also kind of drop scopes easily enough as well. No, I like that. I have a feeling I would keep that for the final language. Yeah, I like that. So what's left to do with oh, is that functions implemented? That might be functions implemented actually, because that's the scoping rules done. So what's happening with line 97? Result must be used. Yeah, that makes sense. All right, that is that's cool enough. So if I go back to the snippet I had at the start of today's session, and I uncomment that. So what we're looking for here is, first of all, we should get an error to say that A is undefined when, so we'll be calling Y, and so we'll be getting an error to say that A is undefined because it's trying to access this scope. In fact, this on its own is going to cause an error to say A is undefined because it's not defined with a declaration syntax. So we get A isn't defined here. So then we do that and we get A isn't defined in Y. So maybe A is equal to 0 here. So then next we should get the value 4 gets output, and then we get another another error saying Z isn't defined. So yeah, 0 gets printed out, and then Z assigns 4 to A because it's in that scope. And for example, we could have another A out here as well. And when we print A out here, oops, maybe I'll do that to be 10. Anyway, back to where we were. So let's see, outputs 10 for this, yes, because this is accessing the, no, that's wrong, is it? So, okay, there's a bit of jumping around, so let's take a look. So X goes in here, we define A equals 3, and then we call Y. Y creates in its own scope A, then prints A. A should be 0. That's a pity. That's a pity because that's not what's meant to happen. A should be assigned to 0, and 0 should be printed there. Okay. So then what happens next? I'm not even sure where it's getting 10 because there's a does it go from left to right when it's cycling through the scopes? So I'll have to actually reverse. Very, very interesting. So I'll have to reverse reverse that loop. Rust reverse iterator. .rev. Can I just put it on like that, I wonder? It would probably actually make more sense instead of reversing it every time. Although, if I pushed the new one onto the start? Rust vec. And check out these extra functions. Maybe rev would be efficient enough. I mean, how inefficient can it be to go backwards through a memory mapped list? Oh, do I have to call iter first? Yeah, maybe. That slice is not an iterator. Try removing the reference. Okay, whew. And then that means that that's being assigned correctly. Okay, whew. Then, so we get a equals 0, print a is equal to 0. Then we go z, call z, a is assigned 4, overrides the one in the closure. Print that after we've returned from z and we find that our local a has been updated from 3 to 4. Nice. And then we return from x and z is no longer defined. So what we can do is, this is bad from a type point of view, but we'll assign z to 0 first. And then once we get to the end, it'll output saying z is a function. No. Oh yeah, z isn't a function. So so maybe we'll define z out here as this. Yeah, this is all looking fairly nice so far. Print a is 20. If I do nothing in z, actually, what gets output from z? So z does nothing here. A won't have overwritten this one now finally, so 10 gets output at the end. That's very nice. All of those are working basically how I'd expect them to. So let's get back to the initial snippet that kind of was kicking all of this stuff off, and the only thing is that has introduced a new syntax. Unless I want to make equals the declaration syntax. No, you're going to be probably assigning things more often than you're declaring things. So no, we'll keep it like that. So okay, so yeah, functions are now implemented. So let's see what this does. So this was going to be just an early test of that. So we go define x, print x, that gives 3. Define function is less than 2n. So print the result of that. So we don't have return values just yet. So that's going to print null when it actually gets printed. And in fact, am I adding those brackets myself, or is... Oh no, that's because that's the arguments list to the function. That's all right for the moment. Anyway, so is less than 2, 1, and so n should be set to 1, and y is set to 4. So first we should output 4, yeah. Then it prints n, and n should be set to 1. Yup. Print 1 is less than 2, that's true. And then x is less than 5, that overrides this guy out here. Function returns, at the moment functions only return null. And then we print x, and it's been assigned to 5. That is very nice. I'm happy with that. Brilliant. So, and then next thing to do is to implement division. So this programming language doesn't have division yet. So that should be a lot less tricky than implementing functions. So I'm probably going to leave it there today. Pretty happy with how that went in the end. Got function calls working, got scopes acting how I want them to work, have variable binding using both assignment and declarations, so we can refer to different levels of scopes. Fixed that issue with the like moving through the scope stack in the wrong direction.
Sometimes the mic messes up a bit when I'm putting the headphones back in the case, but or the earphones. So yeah, so then the next thing I'll be doing is working on like adding support for division. Then once that's done, that's actually a big chunk of the features implemented for this language. Like there'll be a bunch of operators to do still, but that's a huge chunk of work done so far. So I'm just going to give a quick look at again the snippets that I had with this originally. So let's see. There we go. So yeah, so next I'll be looking at functions as first-class citizens, but I believe this should be handled out of the box. Basically, like functions are values at the moment, so that should be happening naturally for what we have now. There's also this kind of syntax for generating I suppose arrays of integers that'll need to come, and then after that, so there'll still be a bunch of features to implement, but they're things like I think maps is a big one that I still will need to implement. What other value types will there be? So I'll have to implement a bunch of operators. I'll be doing map, structuring, destructuring, an assignment like that. I'll be adding a few other basic value types, so I'll have built-in support for null. I know some people are probably cringing to hear that, but I think it would be necessary. Again, it's a lightweight language. It would be nicer to have proper option support, but then the objective of this language isn't, again, to be a general purpose language that you're going to write huge software products in. It's really going to be more a glue type language for sticking other languages or other programs together. And again, in the spirit of keeping things light, null probably, again, because there are no types, and no static type checking, it's going to, having an option type would be essentially equivalent to having support for null. So I'll probably be adding null in. So we've integers and strings. I'll be adding booleans, and at that point, then, are there any other control structures that I need? So I won't be adding exceptions to this language. I'll be doing a different kind of structure for that. But yeah, for the most part, that is more or less. Yeah, I don't think there's too much left, which is pretty nice. So in fact, just looking at it there, actually, I probably don't need to separate the program into this separate body thing. If I'm returning a vector of statements directly, I can use my my special syntax to collapse those. In fact, I might just try doing that now before I finish off today. So we get a program parser. It should always return, in this case, if I take a look at a val, it'll always return a program body, which is made up of statements. And then, so if I get statements, then I can go eval statements in new scope. So oh no, so this would just be eval statements, and so this would have so again, global frame will be instead global scope. I won't need to do any of that stuff. I'll just put global scope there. And this will then be just an empty ScopeStack. Okay, that didn't go quite as smoothly as I thought I would. I thought that would be a nice simple improvement. Expected immutable ScopeStack. That's easily solved, I think. Expected one argument but supplied none. Let scopes what did I have there before? And so that will get rid of the need for that even. No need for mutex and arc in here as well anymore. That's kind of nice for free. Prog body, where is that coming from? That's an AST thing. I probably don't want to. although it's going to have access to the AST somewhat anyway because it's parsing it. Maybe I should have left this. I'll put it back to the way it was, I think, for the moment anyway. And I'll resolve that once I have a bit more, once the weather has calmed down a bit. And that was due to the division. Yeah, that's alright, so. So yeah, I think I'm going to leave it there today anyway. Very happy with the amount I got done, and yeah, looking like fairly clear sailing for the rest of the function stuff anyway. So looking forward to diving into that. Should I save what I have now? Yeah, I think I will. So let's see what changed. Yeah, declarations, function values. Yeah, a lot of stuff changed. Bit of refactoring in the middle of the change as well. Probably for the better, though I could have split that up into a separate commit. Okay, introducing some white space errors there. Let's see if I can remove those. And then no verify. Oops. Oops. Add support for functions. Function declarations and calls. Nice. That is cool. I'm very pleased with that. Nice one. So thanks everyone who checked this out. I know it was a bit of a good period of me just kind of sorting through things in my own head and just kind of getting lost in the refactoring. But yeah, thanks for checking it out, and see everyone next week at least. So yeah, have a good week and talk to you then.